StarWind software, Hyper-V, and high availability storage. You know, as the title had indicated on the webinar as well, we're going to talk a little bit about, you know, managing your Hyper-V environment, utilizing things like live migration that requires shared storage, really creating that high availability scenario from, you know, both the storage aspect as well as at the application layer or the Hyper-V layer via Microsoft Cluster. So we're really going to pack a lot into the next hour, as you can see here on the agenda slide. Now, I generally try and break these up as close to half and half as I can, but we're going to start off with some PowerPoint presentation, you know, a little bit on SAN technology, you know, iSCSI in general. We're going to talk specifics around iSCSI and Hyper-V along with Windows clustering, how all of that fits together using storage high availability with MPIO, and then, you know, obviously that this sort of introduces the idea of clustered shared volumes and the role that they play in terms of load balancing workloads across various nodes of your cluster and being able to move those workloads around using live migration. You know, then we're going to get into the live demo aspect of this, where we're going to talk a little bit about what you need to put something like this together, configuration of hardware and software, review of clustered storage, so the StarWind high availability, how to go about creating high availability storage to support your Hyper-V cluster. We'll look at the use of live migration, and then we'll wrap up the live demo portion with an overview of Microsoft System Center Virtual Machine Manager, where I'll take you into that sort of user interface, give you a feel for how that works. And the reason I like to do that is obviously when you start building out a Microsoft cluster, there are 4 or 5 different interfaces that you can use when you're going to go ahead and manage something like this, whether it be the Hyper-V manager on the individual nodes, whether it be the Microsoft Cluster interface, or it's some flavor of System Center, you know, Virtual Machine Manager, System Center Essentials that you're going to use to go ahead and monitor and manage these virtual machines on a day-to-day basis. So we'll hopefully leave you with a flavor of what that looks like as well. You know, and then finally, you know, we're going to wrap up with some Q&A. The Q&A, you know, it's really important when you have a question to go ahead and type it right into the GoToWebinar chat box or the question box, so you can go ahead and get that recorded. The way I work my Q&A is I work in as many live questions as I can at the end. Any of them that I either don't get to, and there could be 2 reasons for that. One, I just don't have time. We don't have the time to get to it because we do try and keep this as close to an hour as possible. Or, admittedly, I just don't know your answer. And so in which case, I'll do the research. If I don't have time to get to your question live, it will be recorded via the GoToWebinar user interface there. It'll come to me in a spreadsheet form, and I'll be able to reach out to you one-on-one and make sure we get answers to any and all of your questions. So don't despair if for some reason I don't get to your question live. I will get you an answer, no question about it. So with that said, I want to go ahead and jump right into the presentation itself. Now, for those of you that have heard me speak in the past, you know that I always like to start off these types of presentations with this slide. And it's always interesting to sort of look at and talk about what are your options, obviously, when it comes to supporting your Hyper-V environment. You know, and obviously, you know, there are a couple. First being, you know, your local or direct attached storage. So you can go ahead and create pools of servers, you know, each with their own independent resources, and, you know, ultimately go ahead and virtualize that way. And so what you wind up with there is, you know, a scenario where each server or each Hyper-V host is like a small island, and you're going to go ahead and host the virtual machines there. You still get all the benefits of consolidation, obviously, because you're going to take better advantage of the resources in each one of those boxes. However, the major drawback to that is, and as I indicated before, each Hyper-V host becomes an island. And so, you know, you're in a situation where you don't have any real high availability within that host. And the reason that's so important, and I think that, when we look at high availability in the traditional sense, we always thought about a SQL Server cluster or some other type of application cluster. It's even more important now with Hyper-V because, or any virtualization platform for that matter, because those servers now have a much bigger footprint when it comes to the impact of a failure. Because now no longer are you just hosting a single application, it's 5 or 6 or 7 different applications that go down when that host dies. Which brings us to the second option, which is the shared storage option. And then when we talk about shared storage for creating that cluster, we're talking about, some of the traditional, sort of ways of going about creating or connecting to an external storage array through an HBA or something along those lines. Something like what you see here, fiber channel, or what we're going to talk about today, iSCSI. Now, on the fiber channel side, obviously, this is sort of a technology that we've all heard about if we're not familiar with, and obviously it's a technology that's been around for quite some time. It certainly is something that we've seen used quite extensively in some of the larger organizations, and the reason that is based on the fact that this is a very, very cost-prohibitive, I guess you could call it, technology to implement, and that, it's worth every penny, don't get me wrong. I mean, there's nothing bad to say technically about fiber channel. I'm not here to bash that. However, when we start talking about the proprietary nature of an implementation of a fiber channel SAN, we're talking about everything from the host bus adapters that need to go in each server, the switch that needs to be utilized, the cabling, all the way down to the storage boxes themselves. And so you find yourself in a situation where a lot of us are simply priced out of this market. This is not an option for us because we simply don't have the budget to implement something like this. We'd all like to, and we'd all, no one ever got fired for implementing, the best of the best. However, that's not always an option in the real world. And so, whenever we undertake one of these virtualization or server consolidation type of projects, we always think about, and we're always pitching the positive ROI of consolidation. Well, nothing puts a, sort of a dagger in the back of that positive ROI like an extremely expensive storage subsystem. So it really has to make sense for you to do something like this. If it doesn't, then there are alternatives, which is why we're here today. Now, and I like to, again, admittedly, these are very rudimentary diagrams, and they're just meant to sort of show you the overview of what something like this would look like. This looks awfully familiar to what we were just looking at, and I think that the main difference here is when we start talking about iSCSI, we start getting into commodity hardware now. We're no longer talking about anything proprietary. We're talking about hardware that you can buy. It's off-the-shelf stuff. In a case where you're doing a server consolidation, you can even go so far as repurposing that existing production equipment if it's still got some life left in it. And, obviously it meets the appropriate criteria. So obviously, we're talking about, standard gigabit networking or 10 gig if you've upgraded the network backbone in your organization to that. Standard switching fabric, so there's nothing proprietary here about the switch, although we are, as you're going to see in my later slides and in my demonstration, the need to isolate this traffic, but we're still talking about utilizing sort of commodity-based hardware for that. And when we get down to the iSCSI boxes, there's a couple of alternatives that you have as a consumer of this technology. One, you can go with sort of the more higher end, sort of appliance-based solution, or you can go with a software-based solution. Now, obviously, both have benefits, both have, drawbacks, but I think that, when we start talking about, looking at the hardware-based solutions, and again, the cost that's associated with them, what you're getting for what you pay for, and your ability to go ahead and really build out an iSCSI infrastructure that's going to come in at a budget, but yet also meet your needs. That's really where the flexibility of that software-based solution really starts to come into play. But, I think that the bottom line here is that the iSCSI SAN looks a lot like what the fiber channel SAN does. The only difference is we're swapping out a lot of the more expensive equipment for more commodity-based equipment or standard equipment that we can utilize to build out our iSCSI SAN and really support that application layer, in this case, our Hyper-V cluster. Now, there's a lot of different reasons to really talk about or consider central storage and central storage management versus, the more direct attached approach. I think I covered one earlier in terms of, painting a picture for you of what your Hyper-V implementation might look like. But I think there's also, a lot to be said for that sort of central or pooled storage management approach outside of, all of the obvious reasons when you're virtualizing in terms of high availability and fault tolerance. When we start talking about that central management of storage resources within an organization, we now start to have the ability to manage those resources much more efficiently. If I've got 5 servers and they've all been spec'd out with 2 terabytes of storage each, and I may be using a half a terabyte on one, a terabyte and a half on the other, a quarter of a terabyte or 250 gigs on another. It's horribly inefficient to go through the process of having, spindles sitting on a box that are just turning and consuming power and not really doing anything. That central storage management approach allows you to stand up the storage that you need and then ultimately make that storage available over the SAN network. So whether it be fiber channel, iSCSI, NAS, whatever the case might be, stand that storage up as you need it, parse it out as you need it to those application hosts or to the consumers of the storage, in this case Hyper-V, and really, just bring on the storage that you need as you need it. So that efficient use of storage resources, the ability to go ahead and do things like storage tiering. So, if you've got, a 3-box configuration, maybe one iSCSI box has the slower SATA drives, you're using that for archival and backup purposes. You've got, 15K SAS drives in another, and then you've got some solid-state disk in another. Again, tiering that storage or making sure that the investment that gets made into the more high-end or expensive storage assets is actually parsed out and utilized by the applications that require it. Then there are a bunch of sort of SAN level or sort of data level protection features that the central storage management approach is going to be able to offer you. Obviously, doing things like block-level-based replication, volume-based snapshots, which, again, are based on changed data blocks, which are much more efficient, and that the block-level replication being much more efficient than anything that you might do at the file level, and being able to go ahead and implement those things and sort of shift some of the responsibility from data protection from the actual application servers down to the SAN servers, where you've got abundance of resources, whereas at your Hyper-V servers, resources are precious. And so, there's a lot of opportunity there from a central storage management perspective. And then obviously, some of the stuff we talked about earlier in terms of unlocking enterprise features. When it comes to virtualization, losing one server now has a tremendous impact in terms of the number of applications that could be hosted and the number of data sources that could be being hosted on that server. So having some fault tolerance, whether you're using VMware, Hyper-V, Xen, whatever the case might be, and being able to create those clusters so that you can go ahead and create fault tolerance or failover for your virtual machine so that you eliminate that single point of failure is all a critical piece of that sort of central storage management piece versus direct attached. Now, the next slide here talks a little bit about why iSCSI, and we start getting into some of the benefits of iSCSI. And I think that I really should get around to changing this slide because it's not only why iSCSI, but I like to talk about why software-based iSCSI. And I touched on it earlier, but when we start talking about iSCSI as a protocol and sort of why you want to consider it versus fiber channel. I think that the case has been made, and I think most folks would agree that it tends to be a more cost-effective solution. The other side of that is, it's just, from an ongoing, so get past the idea that you've got a barrier in front of you in terms of your initial implementation. Let's move, 2 years, 3 years, 6 years down the road when it comes time to maintaining this and managing the storage network. Again, we're talking about, the non-proprietary aspects of iSCSI and the ability to go ahead and be able to manage this with the skill sets that you have in-house, and really making the ability to add shared storage to your environment and add all those benefits of central storage management for a fraction of the cost of what you might pay for a more traditional fiber channel type of solution. And then we get into the software end of it, and again, I think we're talking about, when we talk about why using software to build out your iSCSI SAN, it really boils down to flexibility. When you choose to go ahead and utilize a software-based solution, you maintain that freedom to, again, choose the hardware. And for some of us, we want to be told, what to buy and what hardware we want to put this on. And that's great. That's fine. And certainly most software-based iSCSI vendors will give you a list of things that you can, they'd like to see you run their equipment on. I know we certainly will. However, if you're interested in sort of building this out, if you have a number that you're working backwards from, the software approach really allows you to go ahead and tailor the solution to the needs of those front-end servers. So, you're going to be able to go ahead and either do, internal storage tiering within a box where you've got, a RAID set made up of SAS drives, a RAID set made up of SATA drives, and maybe you throw some solid-state cards in that box as well. Or you split those up amongst 3 boxes and you tier that way. Or, if you can't really afford some of the faster drives, maybe a software-based strategy allows you to go ahead and implement some of the higher density SATA drives and make up for some of the loss in performance utilizing, RAM as cache. So lots of different opportunities there to make sure that we can bring a solution in that's going to meet the budget that you have and also help you sort of plan this out so that you're going to be able to make sure that it's going to meet the needs of the application servers that are consuming the storage. This is another slide that, quite frankly, I tend to leave in only because it's hard to know exactly who's in the audience when you do one of these things. And so I always like to talk about what is iSCSI, just in case somebody's new to this. Essentially with iSCSI, we're talking about traditional SCSI disk commands that, normally would flow over your internal host bus adapter. Those commands are going to be encapsulated via TCP/IP, and pushed down to, the actual storage arrays themselves through an iSCSI initiator. That iSCSI initiator could be software-based, it could be hardware-based, depending on the makeup of your setup. iSCSI from the Windows perspective, from the StarWind perspective, is going to run as a service on the storage box. So, what most customers are doing these days is they're, taking a Server 2008 core box, it can be just a standard box, it doesn't have to be an enterprise or data center, and installing that OS, loading it up with, 4 to 5 NICs, and then loading it down with storage or attaching it through an external RAID controller to, a storage cage, presenting all that disk up to Windows, and then parsing that out via the storage virtualization piece that comes with StarWind. So, it's real straightforward in terms of what iSCSI is, if you think about how it travels from the initiator down to the storage box and back. So, and again, we're talking about, from a networking perspective, that commodity networking. So, gigabit backbone, 10 gig E. If you're upgrading your environment to 10 gig E, your iSCSI SAN will just be, a nice beneficiary of that. So there'll be another reason to consider doing that type of an upgrade. So, but that's just the basics of sort of how iSCSI works and what it is. and again, this is a slide that I know that we've touched on a lot of this stuff, and I have a bad habit of sort of getting ahead of myself with some of these. But, again, with the benefits of iSCSI and software-based iSCSI, that familiarity with networking standards that you're already using. The ability to do things like replicate data, whether it be, setting these up in an active-active array for high availability, or an active-passive array for replication of data to a DR site, or to be able to do things like create rollbacks for yourself. So you're using volume-based snapshots, so you can actually roll back or do file-level recoveries. And really get down to the elimination of the cost of the overhead that's associated with proprietary hardware, proprietary networking, proprietary cabling, buying a black box from a vendor without any real ability to tailor it either via initial setup or, 6 months down the road when you want to add storage to the box, add a NIC to the box, add more memory to the box. These are all things that are possible with a software-based solution. And then obviously, one of the things I always like to throw in here is, iSCSI will always fit well in a sort of bigger tiering type of scenario. So if you're somebody that is either already implemented fiber channel, we see a lot of large companies coming to us to talk to us about that storage tiering. So they're running out of space on their main SAN, and they're looking for a more cost-effective way to maybe offload some of that Tier 2 or Tier 3 type data off to something else, or they're looking to implement the solution at a remote office. iSCSI is a real big winner when it comes to being able to do things like virtualize, servers or use virtual desktops at remote office locations. So, if you don't want to spend the $70,000, $80,000, $90,000 to build out a SAN for your 5 locations, you simply want to just go ahead and create shared storage at that remote location using some commodity hardware, then obviously iSCSI is something to look at. Some of the performance best practices, and again, I think this is important only because I'd like to make sure that everybody that sort of looks at this may run off and decide that they want to go ahead and try this on their own. So it's always important for me to go ahead and go through the process of talking about this. So, what I like to do is talk a little bit about sort of some of the best practices when it comes to, the more generic best practices when it comes to iSCSI storage. And then obviously, if you're somebody that is interested in talking about tweaking this for your individual environment, then obviously that's something that we can talk about one-on-one. First and foremost, network isolation. This is very important from an iSCSI perspective because we want to make sure that this traffic is not competing for bandwidth with anything else. So whether you utilize a separate switch, if you've got something that's a little bit more robust, you could always VLAN it off. But we definitely want to do that level of network isolation. The use of dedicated NICs in your application servers. So in your Hyper-V boxes, for example, you may create, VM networks and bind them to, specific NICs in your box. Then you're going to take, a couple of other NICs in your box and you're going to dedicate those to iSCSI, and then maybe put a 5th port in that box for management. But certainly, again, you want to make sure that you're isolating, this scenario here so that there isn't any sort of network congestion or network contention. Gigabit networking, obviously, I think that it's important to say that, and then obviously scaling up to 10 gig E if that's something that your company is looking at implementing. Things like network optimization. So, enabling jumbo frames, is something that, we like to see done only because, let's take advantage of everything we can, right? So let's make sure we maximize the frame size that's utilized by the network. The TCP/IP window size optimization, that's something that really isn't necessary anymore in 2008. So, if you're running a 2008 box, if you're running, obviously if you're running Hyper-V you are, but if you're running it for your storage box, you don't necessarily have to worry about this anymore. And that Windows 2008 with the redesign of some of the elements of the TCP/IP stack actually handles this for you. Things like, getting down to the disk subsystem, that's another area where I see a lot of folks that wind up getting themselves into trouble. Things like matching disk speeds with I/O loads. So, obviously configuration of your RAID set is key. So you want to make sure you think through what RAID set is going to be best for you based on the overhead that you can afford and the level of protection you want at the disk level. Use of proper disks, so matching the workloads with either SAS, SATA, or solid-state disks and the different densities and speeds of those spindles. And then obviously matching RAID sets with I/O patterns. One of the common mistakes that I see made is, customers will come in and they'll immediately start running these virtual machines, and one of the virtual machines will be sort of act as a storage head for a backup server. Well, that's going to be a lot of sequential, large block sequential I/O, and that running into on the same set of spindles as, say, your highly transactional, sort of random I/O based SQL server or SharePoint server, that's going to cause some I/O bottlenecking at the disk subsystem level. So it's important to sort of look at that. And then lastly, things like monitoring. These things can't be just stuck off in a corner somewhere. You want to make sure you monitor. You want to make sure you've got controls over, which VMs are hosted on which sets of spindles. These are all important things because, as time goes on, when you initially set this thing up, it's optimized. But after you get, and the one thing about virtualization is, everyone thinks that virtualization is free, and it's very easy to stand up VMs, and it's quick and easy to deploy them. That's great, and that means that the landscape is going to be very fluid. So you want to make sure that you're monitoring things, from a disk subsystem level in your storage boxes. Something as simple as average disk queue length and making sure you're monitoring the disk queues to make sure you don't wind up with bottlenecking at the disk subsystem level. So again, just some tips there in terms of some more generic performance practices that you want to make sure you're considering as you're building something like this out. Now, we touched on this earlier as well in terms of data protection. Obviously, I'm a big advocate of the traditional backup. If I could throw a commercial in for a second, I'm a big fan of utilizing Microsoft Data Protection Manager 2010 with your Hyper-V environment. I look at it as, the one throat to choke if there's ever a problem. But, obviously, some of the things that we're going to be able to do, or the SAN technology that you choose is going to be able to do, things like doing block-level replication, so replicating data from Site A down to Site B for DR purposes. Creating high-availability storage. Well, you've created this high-availability cluster for your virtual machines. Why let it bottleneck at a single point of failure at the storage level? The point-in-time snapshots we covered, again, a little bit more efficient than what you might see at the VM snapshot level, and that we're doing the deltas at the block level, so we're creating the ability to go ahead and this is actually something that is really interesting, and that a lot of customers have implemented a scenario where they're doing their protection of their virtual machines through DPM. Then they're presenting snapshot-enabled virtual disks directly to those virtual machines themselves to act as data repositories or data volumes, and ultimately backing those up maybe on a nightly basis, but using the snapshots, the volume-based snapshots, to go ahead and create restore points for themselves throughout the day for the volumes themselves. Being able to secure your storage, so things like CHAP authentication, IPsec, LUN masking, and doing things like making sure that certain servers can see certain iSCSI LUNs while others can't, are all very, very important. And then obviously the high availability storage, utilizing MPIO, which is something we're going to talk about in great detail today. Now, we're getting closer to the end of the PowerPoints and closer to getting over to the actual live demo, I promise. But this is sort of the big picture, and it's hard for me to show you this through a demo, so I like to sort of review this real quick. And this is sort of a scaled-down model, if you will. So essentially, what you'll see here is I've got, my Hyper-V setup over here, where I've got a 3-node cluster in this case. I've got my dedicated switch for iSCSI, and then I've got my StarWind boxes over here, or insert iSCSI box here type of scenario. Essentially, what I'm doing here in this particular configuration, I'm running a high availability storage scenario where I've got an active array. So what I'm doing here is I've taken my StarWind boxes, I've set them up. I'm presenting storage that's being synchronously replicated across the StarWind HA sync channel, which I'm just, in this case, I'm representing via a crossover cable between these two boxes. What essentially StarWind is doing is presenting or creating two virtual storage devices, one on box 1 and one on box 2, that actually makes up the actual storage device that's being presented to Windows via the MPIO driver. And ultimately, what's happening then is that Windows is seeing a minimum of two active paths to this storage. So basically, I'm seeing path A, which is going to end at node 1 of StarWind, and path B, which is going to end at node 2 of StarWind. And as you'll see during the demo, I can set my path selection policy to something like round robin. So what round robin will do is it'll attempt to load balance the I/O across all of the various paths to the storage. And so if a data block is written to node 1, that synchronization channel ensures that it's also replicated down to node 2 and vice versa. So I'm going ahead and creating that high availability so that if I were to lose one of these storage boxes, my cluster here would continue to function. It would simply show a series of dead paths to the storage, but would still have remaining paths available to it via node 2, or vice versa. Now, obviously, the other thing I'm representing here is the use of the clustered shared volumes, where I'm basically presenting these clustered shared volumes. I'm attaching to them as clustered disks first, and then adding them to clustered shared volumes, which is creating mount points for those disks in each one of these nodes. And obviously, the benefit of clustered shared volumes is it frees that sort of link between the volume and the VM. So now I can run VMs on, say, one of these clustered shared volumes. I can move the VM around the nodes in the cluster without having to change ownership of the underlying storage as well. So the clustered shared volumes brings you a little closer to that clustered file system that a lot of us have seen with VMware and their VMFS file system. So it brings us a little closer to that based on the way Microsoft has done this and provided us with a lot of flexibility in terms of load balancing and the flexibility around how we structure our storage. Now, a little bit of a closer look at MPIO, from a high availability perspective. When we talk about an active iSCSI array, we're talking about two independent boxes. So iSCSI node 1 and iSCSI node 2 are completely independent boxes. They're not, we don't have to set up Microsoft clustering on them. We don't have to do anything to them at all. Basically, just install the Windows OS and then, install StarWind on both nodes and then create that high availability storage device that I'm going to show you here in just a moment. And that ultimately gets presented down to your Hyper-V box as a multi-path device. And so, depending on how many NICs are in the Hyper-V box that are dedicated to iSCSI and how many NICs you've got in your iSCSI box, you could have, 4 paths, 6 paths, 8 paths to that storage. And if you added a second switch in here, again, because this is the glaring piece here that is a single point of failure, you could simply run paths to that storage through a second switch as well. So again, you're really sort of creating that level of fault tolerance that you get with Microsoft clustering for your Hyper-V virtual machines. We're now extending that over to the storage aspect. And then clustered shared volumes, for those of you that aren't familiar, and I'm sure most of you are if you've been playing around with Hyper-V at all, or if you're somebody that's implemented Hyper-V, again, we're talking about the ability to access a piece of storage, from multiple nodes in the cluster to be able to go ahead and host 3 virtual machines on one piece of shared storage and have those virtual machines were all running on different nodes in your cluster. That's really the benefit, which, a lot of you that maybe have implemented the initial release of Hyper-V remember that, you could migrate from one to the other, but the storage ownership had to move around with that. So the Hyper-V, the virtual machine was tied to a given piece of storage, and that storage moved around. Ownership of that storage moved around and could only be owned by a single node at a time. So, again, a very, very important improvement, from the clustering perspective from Microsoft. Now, I'm going to go ahead now and pop over into more of the live demo aspect of this, and so this is really where I'm going to get into the start of sort of how something like this looks in an actual production environment. Now I'm going to start off with the storage, then we'll make our way over to the iSCSI initiator on the Hyper-V boxes. In this case, I've got a couple of server core boxes running Hyper-V, where I'm using a tool called Core Config to be able to stay away from having to do a ton of command line stuff. And then, once we go there, then we'll move over to some of the management interfaces. So we'll look at the cluster management MMC. We'll look at the system, center virtual machine manager, and sort of, some of the different things you can do there as well. But let me start by creating some high availability storage. So, the way this works, and this is the StarWind user interface where we've got basically, I've got 4 storage nodes that I've imported into this interface. And ultimately, from here, I can manage any one of these 4 nodes. I'm going to start off with Hyper-V Node 1. And what I want to do here is I want to create a sample high availability storage device so you can get a sense for what that looks like. Now, bear in mind, and this is probably more geared toward our getting started sessions, but I've installed the user interface. I've set up on my operating system, I've installed the StarWind piece to this, and then I've configured the rest of the disks in these servers so that they're going to act as a host for virtual storage devices. So, I'm going to go ahead and click on the Hyper-V Node 1, and I'm going to add a target. Now, this is all wizard-driven, so it's pretty straightforward. We'll call this Demo July 21. And it's going to ask me a series of questions, basically, and this is how it's going to come down to me creating this target. Now, for the purposes of the demo, we're going to stick with hard disk. That's what most of us are going to want to do. We're going to want to use hard disk as a medium for our shared storage device. And in this case here, I'm going to actually use an advanced virtual device. Our advanced virtual, and think about our virtual storage devices as almost like Microsoft virtual hard disks. They're pools of storage that we're actually going to assign to physical storage assets in the server. So in this case here, I'm going to choose Advanced Virtual. And these are some of the options that I talked about earlier. So whether it be an asynchronously replicated device, which we call a mirror, a snapshot-enabled device, or in this case here, a high availability device. So I'm going to go ahead and create this high availability device. Now the first thing it's going to ask me is, where's the partner server? Where's the second server in this active scenario? So I'm going to go ahead and give it that, and we'll log in. So it goes out and does a quick check to make sure that it is indeed that server is there, it's standing up, and it is running the iSCSI service. It's going to go ahead and create a partner target on that server for me as well. So it took the name that I gave the primary and just added the word partner to the end, which that's fine. We'll leave that set. Now this is the part where you're actually going to create the virtual storage devices on either server. So this is the current server, so this is Hyper-V Node 1, and then down here is my partner server, which is going to be Hyper-V Node 2. I'm going to go ahead and create 2 new virtual storage devices here. And we'll do some demo files. 21. And down on the partner server, I'm going to go ahead and choose here where I want to create this as well. Now you'll notice these are the actual physical volumes, or the logical volumes that I've created within Windows that are backended by physical disk. So I've presented these volumes to Windows, and now I'm going to go ahead and assign these virtual storage devices to a given physical storage volume. And I'll just create a small 256 meg device for the purposes of the demo. Now, the next step here is obviously going to be one of great importance from the perspective of, we really want to make sure we get this right. We're going to be going through and actually selecting a synchronization channel. Now, if you remember from my diagram, I showed the synchronization channel. I represented it as a crossover cable. This is a critical aspect of high availability storage because your path selection policy is going to choose which server a particular data block is written to, and it's only going to be written once. So, as it load balances across, if you've selected round robin, as it load balances across all of these, you're going to find yourself in a situation where, the data block is going to get written to one of these servers, and it's going to travel across that synchronization channel to get down to that other server. And it's critical that that happen because obviously if it doesn't, then if one of those servers were to go down and the data was inconsistent, you'd wind up with a pretty big mess. So, we're going to go ahead and select that synchronization channel. We generally suggest that's something dedicated. This is the one rare instance where, in an iSCSI scenario, where I'm going to recommend teaming. I generally don't recommend teaming. You generally use MPIO to get, bandwidth spread out across multiple paths of the storage. But for the sync channel, plugging these, again, via crossover cable and teaming those ports together, or teaming the ports and running them through two separate switches so, again, you don't wind up with a single point of failure, will be critical. Now I'm going to go ahead and clear these virtual disks, which will zero these out. I'll get better performance because I'm going ahead and zeroing out these virtual disks ahead of time. And then this is where I can go ahead and use caching, as I'd indicated earlier, to increase or improve the performance. So if I want to oversubscribe a set of disks from an IO ops perspective, if I've got some slower disk, because I simply don't have the budget right now to go out and purchase the fast or low-density drives, I can utilize or leverage the physical RAM in my sandbox so that I can go ahead and cache that I/O. And again, make it, give me just that much better throughput when it comes to actual data moving between the initiator and down to the storage. And what will happen is that pool of memory will be reserved for this target on both sides, and as data is written to it, it'll be dropped off with that particular piece in that particular area of memory, and then flashed down to the disk as quickly as possible. So, and you can use a couple of different types of caching, right through versus right back, which is a topic for another day, obviously. But in this case here, I'm just going to leave it set for no caching because I'm just setting up a demo device. And so it'll go ahead and create my target for me, and I can finish that up. And it will go ahead and clear those nodes out for me. Now, what you wind up with, as you can see here, is you wind up with a target on either side. And as you can see down here, I've got my Hyper-V cluster. I've got my Quorum partner and my Quorum device down here, and I've got a couple of data stores, highly available data stores that I've created that are ultimately being utilized by a Hyper-V, a small Hyper-V cluster that I've got running here in my environment. But that's the essence of creating the high availability storage. And again, once you've done that, you're now in a position to come out to your initiator side. In this case here, I'm running a couple of Hyper-V boxes that are running on the server core. And so all I've got to do is come out here. Now, obviously, from a configuration standpoint, you've got to install the Hyper-V role on the machine. You also need to install the MPIO role. And again, you can do all this through core config if you're running on the core. Once you've done that, you want to go ahead and plug into Discovery the IP addresses of your storage boxes. If you're using high availability storage, you're going to have a minimum of 2. If you've got multiple NICs in those boxes, simply plug those in, and it will discover the targets across those NICs. Now, one of the things you want to do here as you go through is you'll refresh the list of targets, and you'll see, and I'll use the quorum drive as an example. Here's my, and it's actually just up here a little bit here. Here's my main quorum target right here. And if I look at this, from a devices perspective, and I look at the MPIO, I can see here that I've got a .202 path to the storage and a .80 path to the storage. This represents my StarWind high availability. So what the iSCSI initiator is doing in this instance on this particular node of the cluster is it's going to load balance my I/O load to this particular device across these two paths of the storage with the StarWind synchronization channel in between. If for some reason I were to lose one of these paths, it will simply continue down the remaining active path. So, again, I find myself in a position where I've created some fault tolerance at that level. So, again, very easy to go ahead and set this up from that perspective. Not a lot to it. And if you want to get down to the details of exactly how to set this up, or if you want to get into the nitty-gritty, I'm certainly happy to do that on a one-on-one basis with anybody. So one of the things I forgot to mention is you'll be getting an email thanking you for coming to the session. If you're interested in maybe getting together one-on-one, just hit the reply button to that. Now, assuming you go through and you connect to all your storage from both nodes in your cluster this way, so you've connected to all of your highly available targets, your next step is to actually create your cluster, which, again, obviously very, very straightforward. It will go through and recognize the shared storage that you've attached. It'll allow you to go through and pass the cluster validation, and then ultimately bring you here, which is another spot where you can manage your Hyper-V cluster. Now, if you look here, I can look at the storage that I've got available to me here in terms of this particular cluster, and I've got my witness or quorum drive, and then I've got 3 clustered shared volumes here that I'm actually hosting virtual machines on. And so this is nice to give you sort of a cluster view of what's going on here. I can come down in here and I can do things like, if I selected the edit settings here, it would bring me over to the virtual machine manager. Now, the other key piece here, obviously, and one of the things that I want to make sure I touch on, and there's a couple of different ways to do this, is the live migration aspect. Now, obviously, one of the important things here to remember is sort of the load balancing that's going to go on. So one of the challenges that you have when you implement something like this is you want to go ahead and make sure you distribute the load evenly across these Hyper-V nodes. And so one of the nice parts about this, whether you're doing maintenance on a given node and you need to evacuate, some information or data off of a given node, or if you're going through the process of, just going ahead and changing the lineup a little bit so that you're going ahead and load balancing across, you can simply go through and do a live migration. And this may or may not work only because I've got a bit of a workload going on here, and so I don't know that one of the nice things about this is if there's not enough resources on the target box, it will simply not do the migration. It will fail the migration. But as you can see there, I kicked off a live migration, and so what it's going to do is it's going to move this particular virtual machine, which was running on Hyper-V Node 2, over to Hyper-V Node 1. And as you can see there, it's going through the process of doing that, and now the owner is now Hyper-V Node 1. It still remained on Cluster Disk 2, and Cluster Disk 2 just happened to be owned by Node 1, but it still remained on that, and it sort of moved from one node to another. So again, very, very simple to go through and perform live migrations from there. The other area that is of interest to a lot of folks is the virtual machine manager from Microsoft System Center. And again, I've actually got this installed as part of an overall implementation of System Center Essentials. So I get things like pro tips, which are almost like DRS recommendations in VMware, where it'll make recommendations around load balancing if you want it to. But again, you get a little bit more in terms of managing your Hyper-V environment from here, whereas the cluster focuses on cluster resources and managing those cluster resources. This is a little bit more of a VMware-centric view. So from here, you're going to be able to go ahead and manage your virtual machines, and so I can go in and come in here and look at the properties of a given virtual machine. and look at all of the hardware, statistics or hardware configuration of this particular virtual machine. Make changes to this from here without having to go to the Hyper-V manager. I can do all of that right from here, so it's very, very straightforward. So again, we're talking about a scenario where you're able to go ahead and manage a lot of this right from here. Doing things like your library, so if you want to go ahead and start creating templates, or you want to go ahead and start converting physical servers, all of that can be done right from the System Center Virtual Machine Manager. So again, very, very straightforward, very easy tool to use, either as a standalone or in conjunction with, the System Center Essentials. The other nice thing about this is that they actually allow you to go ahead and manage the VMware Virtual Center servers from here as well. So if you're somebody that's in a mixed environment and you want to go ahead and manage from a single pane of glass, Microsoft has once again come through and done that for you. So, again, very, very straightforward. And, I've mentioned before that I'm managing all this from, the System Center. And as you can see here, this is the System Center, scenario here, the System Center Essentials, where I've got agents deployed out and, are managing. And you can see I've got my virtual machines in here along with all my physical machines. Another nice way to be able to go ahead and monitor and manage this as well. So again, very, very straightforward stuff when it comes to some of the management tools that go along with Hyper-V. Being able to do things like doing live migrations from here as well are another easy thing. And then you can also do things like storage migration. So if you want to migrate the storage from one data repository or one iSCSI LUN to another, you can do that as well. So a lot of great features packed into the virtual machine manager from System Center. And again, either using that in conjunction with the System Center Essentials, where you can get the pro tips bundled in and start getting some of the more robust monitoring, or if you just want to use it as a single pane of glass or a way to manage your Hyper-V implementation, whether it be doing conversions of physical servers to virtual, converting VMware virtual machines to Hyper-V virtual machines. It's all possible right here through the single interface, and it really does make it nice and easy. With that said, guys, I want to sort of put the brakes on the actual presentation here because we're coming up on the hour, and I want to see if we've got any questions. I've put some contact information up here. If you do have questions, or something doesn't get answered and you need an immediate answer, or you're really interested in maybe getting an evaluation going immediately of StarWind, you can certainly utilize some of the information that's up on the screen now. Let me take a look here and see if we do have any questions, and if we do, I'll do the best I can to get to as many of them as I can. Let's see here. Can a folder inside iSCSI storage be used as StarWind shared storage? Yes, it can. And Sana, I'll actually ask you to maybe shoot me a note, because I think maybe we want to talk a little bit further about that. You certainly can do that. There's a couple of reasons why I might not recommend it, but certainly it's something you can do. The next question, creating a cluster gave a failure for SCSI 3 persistent reservation. Why would this happen? Chris, we should talk about it on a one-off. That certainly shouldn't happen. Even if your physical disks don't support it, StarWind virtualizes and supports the SCSI 3 persistent reservation. So if for some reason you were getting that error message, there's a chance you were using a disk subsystem that didn't support SCSI 3 PR. If you're using some of the older disks, the nice part about this is that StarWind does support it. So even if your underlying disk doesn't, but if you're getting that with StarWind, Chris, we should talk about that straight away. So why don't you just drop me a quick line? Let's see here. What are some of the other questions? So I've got one here. What is the difference between write-through and write-back caching? That's a great question. So think about it like this. Write-back caching is going to offer you the best overall throughput and performance when it comes to large write I/O. Write-back caching does, basically the way it works is it's going to write exclusively to the cache. So it's basically going to take the I/O, drop it with the cache, report it back to the initiator as committed. On the back end, our caching mechanism will have a retention period and then flash that down to disk. With write through is a little bit more geared toward, maybe some of the read caching, because what it does is it writes simultaneously to the cache as well as the disk. And so, you're not going to see as big a performance benefit from a write perspective, but you are going to put that I/O in the cache, so if it needs to be read, it'll be there a little faster. So, it's a little bit safer as well in that it's writing and committing to both at the same time versus write back, which is solely committing it to the memory and then leaving it up to StarWind to flash it down to the disk as quickly as it can. And if that's not clear, let me know, and I can certainly show you or talk a little bit more on it one-on-one. Let's see here. Do you have any videos on building up a cluster with StarWind SAN software? We do, Caesar. I can actually, and I'm glad you asked that question. I will get a link over to you. We actually had a couple of Microsoft MVPs that have done just that and recorded it for us. So we'll make sure that we make that available. And what I'll do is everybody that's attended today, I'll make sure that's part of the follow-up email that you get a link to that particular video. Let's see here. What is the big advantage of using StarWind in comparison with SAN hardware? Well, I'll tell you, I think that the advantage comes in mainly in the flexibility. When you utilize software, you get to choose the hardware. So, on some level, every SAN product has got a software and a hardware element to it. The benefits of going with, a software vendor to build out your SAN is really it gives you the ability to go with more of a best-of-breed approach, but also provides you with that flexibility so that you can go ahead and choose the hardware platform that it's going to be built on top of. And when I say choose, I'm not just talking about the vendor. Of course, we're going to give you the ability to go ahead and use HP, Dell, Supermicro, White Box, whatever the case might be. But also, there's a lot of degrees of customization that are going to go on there. And it just, it sort of ratchets up in price as you start to do things like add faster, lower density disks or add more NICs or add HBAs. Those are choices that we think you should be able to make based on your environment. You shouldn't have those forced upon you by a vendor. And so I think that's really where the software approach comes into play, and that's really where StarWind has seen a lot of success, is allowing its customers to go ahead and, with our help in some cases, choose what's going to work best. So hopefully that answers that question, and there's a good understanding out there of sort of the benefit of that, of the software-based approach. Guys, I really appreciate everyone's attendance today. There is, we got another question that just popped in here. Can you use RAID 5 or RAID 10 with StarWind? Absolutely. That's the other nice part about this, and it's worth mentioning, and Caesar, thank you for asking another great question. The disk subsystem itself is going to be separate because you're going to actually construct that based on sort of what you're looking for from the hardware-based protection level, so RAID 5, RAID 6, RAID 10, and again, sometimes dollars and cents will drive what that looks like. However, we're basically going to virtualize the storage. So when you create a storage device, you're going to take that virtual storage device and assign it to one of those physical storage assets in the box. And so yes, with that said, the configuration of the underlying disk makes no difference at all to StarWind. So that's something that we can certainly work with. Guys, again, I really appreciate everybody's attendance. We're going to be doing a number of these throughout the summer, so pay close attention to our events page. I also do offer a slightly more rudimentary session where I get more into the details of actually using StarWind with a getting started that I do every Thursday at 2 o'clock Eastern Time. And if you go out to our events page, you can sign up for that, and you can watch me spend a half an hour actually just configuring different pieces of storage and helping you understand sort of how everything works in a little bit more granular detail. But I do appreciate everyone's time. We have recorded this as well, so for those of you that are interested, you'll get a link to a recording of this session, and we'll make sure that gets out within the next 48 hours. Also, if you're interested in a copy of the slide deck, just send me an email and let me know, and I'll make sure I get you out a copy as well. Guys, thank you very much for all of your time, and let me know if there's anything else we can do for you. We look forward to working with you in the future. Thank you.